favorite after selecting here. I finished testing all the chips. I put them back into their newly case made from simple, very simple paper that I made. And this is the circuit that I was having it until now. Here, at least that part there. And now that I know exactly what is functioning, what this circuit is doing right now is the exact replica of the Proteus circuit that I made. Basically, it is cycling through all the addresses. Well, not all, only through let me think. I believe 5 addresses. It's cycling through 5 addresses, and when it's reaching 000, when you see this 3 LEDs off, it means 000. And you see this red wires here. They are coming exactly from the, well, I'm not sure what to call input or output there from the LEDs, but basically when they are getting positive on their pin, on the pin of the LED, when it's getting the positive, the LED is lighting and is signaling me that is getting a positive voltage. So pretty much is transmitting that positive voltage also to the pin of the address of the ADC. And when nothing, like right now, when it's set to 0, as I set it myself right now, I set it to 0. The address lit up with the pins, with the setting. You know, if I'm changing this potentiometer, it will change here. It will be something else. You see, all 4. This case, because it's at maximum. But if I'm rotating it, let's see now. You see, it's a little bit different. Right now is at the lowest setting possible. That I have 1 second there, or so, or probably more than 1 second. And yeah, one single detail, very important. I had to put back all the ground to ground all the inputs, and also those inputs as well that remained. The input 1, where is the? So here it is. So I put the wire here on input 0, but input 1, 2, and all of the rest are linked to ground. I double grounded there just to be sure, actually to signal me when it's ending that pin there. And because it was remembering, it was staying latch. This output was staying latch for other addresses, and it wasn't shutting off when the address was changing. It didn't shut off. Another important detail that I made here, and I will have to update the Proteus as well, is that I use this button. Like I'm having here the button, but I automated it. I took the signal from the clock itself. When the clock is positive, when this LED is on, is positive, going through this yellow wire here on this line, this red wire here is transmitting that positive into this resistor, 1 kilo resistor that is going to that onto that base of this transistor, and from its collector, its emitter is linked to ground, and from its collector is this black wire that is there. So pretty much I'm shunting with this transistor. I'm shunting to 0 volts. Is actually passing whatever is there through the transistor to the ground, and it's practically like I'm pressing the button to the ground, pretty much, but it's doing it automatically. So this is practically a NOT gate. What I'm doing here with 1 transistor, 1 resistor, and that's it. I'm making a NOT gate. When that is positive, this is negative. Well, is converting that positive signal into a negative signal, and this is the negative signal that is coming through this wire, and the pin, LA pin, is linked to the positive rail here through 1 kilo. So it's flipping from 1 to 0, 1 to 0, from positive to negative. You know, every time the address changes. Very interesting. If I'm using this clock, this is synchronous. I'm synchronizing everything right now. So this is synchronizing clocking, pretty much. This is asynchronous clock, because this is separate from everything. Is its own the clock for the chip itself, and it has nothing with anything, pretty much. This is more logical, what I did here with this clock. When that is positive, not sure when that is positive. Let me check. Yeah, when it's getting to negative, from positive to negative, when it's flowing, when it's going down, is making the change in the chip and in that binary counter, and because this is all that is doing, is changing the binary counter step by step, and the binary counter is doing its job. The other chip that I'm having there is just for checking if everything is working correctly. It's like I got used to do it, but it's not really important. That is not really necessary there. That 7474 with its LED on its output there, but it's signaling me that everything is in order, is working as it should be. It's like a pair, you know. I get used to it. So that's the thing. When that is going from high to low, is clicking 1 bit here, is changing the bit in the binary counter, is counting 1 bit, and it's changing all these numbers here, and in binary, of course. That is 0, 1, and 2. This is how you are numbering them from top to bottom, and this is 4, and now is reset to 0, and when it's reset to 0, is actually actioning, is setting through that NOT gate, is setting this. So this is automatic address calling. I'm calling a single address through this automatic numbering. This is an exercise more than anything. A proof that it can work and it can be done. Pretty much that's all it is. And that the chip itself is working fine. Well, fine. It's working. If I'm changing the potentiometer, let's see, nothing here. Because I didn't put 8 LEDs. I should have. Now it's somewhere in the middle, you see? Yeah? Those 2 in the middle. So let's see, 3, 4, and now should be on. You see those 2 in the middle. And they are a bit more brighter now because I have only one 10 kilo there. A single 10 kilo. Before I linked 20 kilo in series. I made 20 kilo from 2 10 kilo. So yeah, pretty much this is it. That's all I wanted to show you. Well, this is more as a test circuit, a curiosity, if it's working. And this I will not build on its own. It will not be probably this one. I should build it on its own, just a tester for ADC, as a simple tester for ADC. Probably that deserves to have its own board and to plug and play very quickly an ADC and test it very quickly. But this is just a test board, a playground, pretty much. And yeah, I'm pretty happy with it as it is. Everything is running smoothly. Nothing got high. Also, I put the 10 ohms here on the VREF negative here is linked to with 10 ohms. That's pretty much that's it. So now it's functioning. This is what I actually wanted to do in the first place, but it didn't work because the chip itself is having its own a little bit different rules from the original Proteus simulation that I did. All right, here it is, the circuit that I actually this is the file that I did for what I tested in reality. Well, excepting these three guys, I only use one potentiometer there. But this is the logic that I used in reality. This 10 ohms resistors, this button. It's working fine without them here in the simulator, but in reality, well, problems. You can use only one resistor. Like I did in my simulation, I used only one resistor, and the wires got directly to the pin of the LED, and then through that one common resistor that is there. It's working either way. That's why I leave it like that. This is the testing circuit and principle. And here is the actual circuit that I made, the automatic address cycling. Again, this is more like I really played, just to test in reality how things are working and if they are working. And they are working. Okay, fine. Again, I did it exactly as I did it in reality. On address 00 is resetting, is actually setting this value of the potentiometer that whatever I'm moving here, it will display it. So if I will change it to 75, when it will reach 0, yeah, you see it's something else, and doesn't matter. Yeah, and pretty much it is cycling through 5 addresses, only 5. I can change it to whatever number I want, but it doesn't really matter. This is the NOT gate that I used. Actually, this is the NOT gate. Only this. Let me actually use my drawing board here. So this is the NOT gate. This is just something else that it's a part of a logic that you really don't need it. Either you need it or you have to test it to see for yourself if you really need it. But I use it either way because it seemed to be, I don't know, logical. Let's say it was more logical to add it there. And to have a switch from positive to negative and from negative to positive, pretty much. That's why I included, and not from floating to negative and from negative to floating. That's the entire reason I included this, and probably it's a good thing I did it. But that was the reason I put it there. Again, the 10 ohm resistor specifically for this VREF thing that is overheating without ink. I grounded all the inputs. I also put here a text floating inputs, which is a bit of a mouthful, but I will read it for you because you are small and you cannot read for yourself. You are very little. Floating inputs will hold or latch the last output value. So floating input, it means when I'm not linking them to ground, when I'm leaving them in air, just floating, will hold or latch the last output value when changing addresses. So when I'm changing from 0 to 1, on address 1, it will still remain latched the output that I was having, this output that I was having on the 0 address. So when I'm switching to address 1, this will appear as it is on address 1, but really what it is latched. It remained from address 0. That's what I'm explaining here. So it will latch the last output value when changing addresses, grounding all inputs like I did it here and also on the board as well. Because I did notice it quite late, and it is a bit I don't like it, but well, it's a bit hard right now to test everything with this all these ground inputs. But it's better in the final version. If I will build something, I will have to ground them all and unground them when I need them, most probably. So grounding all inputs will reset to 0 the next output of the new unused address. So when it will switch to a new address that is not really reading anything, it will switch all this output to 0. Everything will stay off as it should be, displaying correctly only the accessed address outputs. So pretty much that's what it's doing. Nothing else really. So you have to tweak. It's a little bit tweaked in reality. It's not perfectly as it is here. So keep in mind, if you want to build something like this, keep in mind that nothing is perfect, and you have to tweak it and to adapt it to whatever testing board you are using, pretty much. Okay, that's it. Yeah, thank you very much for watching. I hope you like it, and see you later when I don't know what I will do. All right, bye-bye. From Q12.